The purpose of this value point video tutorial is to cover configuring the 3560 behind the broadband aggregator 4000. In most cases, you'll be adding a 4000 to an existing 3560 installation, so we'll cover how to support your settings on your 3560 through your 4000, which will now be aggregating multiple WAN links into a single network. If you're setting up the two units at the same time, the principles are really exactly the same. So this tutorial should be applicable to either one of those cases. So when you add a 4000 aggregator to your existing system, the first thing that you'll want to do is you want to figure out how to access your 3560 controller behind the 4000. Because your 3560 will no longer have a public IP address, you'll need to use port forwarding to do this. The first thing that you need to do to start this process is to change the HTTP port on the 4000 unit. And this setting is configured under Firewall, System Security. And here we can see the port on this unit that I'm accessing right now is already changed to 8080. By default, this number will be 80. The reason why we're changing this first is that we're going to forward the standard HTTP port 80, to the 3560. And if we do that before we change the web server port on the 4000, we won't be able to log into it anymore. So once we've done this, then the next step is we can go to the port forwarding table and we can start port forwarding port 80, which is now open, to the 3560 controller. Now our 3560 controller has been connected to the LAN port of the 4000. And you can see here I've created a static DHCP lease for this unit, but it could just as easily have a static IP address. And keep in mind that the WAN IP address of the 3560 is always in the LAN subnet of the 4000. So the 4000 handles all the public traffic through its WAN port and then passes that traffic to the LAN port, which connects to the WAN port of the 3560. So our particular 3560 here is at 10.1.1.2. So we'll go to our port forwarding table, which is under the firewall port forwarding, and we'll add a new rule under port forwarding. So the address will be 10.1.1.2. Protocol could be TCP, or you might as well make it TCP and UDP, though HTTP traffic is TCP based, and we'll do it for port 80. That's really all we need to do. We can add a comment that this is the controller GUI, and we'll apply that. Now when we go back to our port forwarding table, we can see that our new port forward is now available. So if we go to the IP address of our 4000 unit, which is 70.133.189.65 in this case, of course your unit will be at your static IP address. But if we go to port 80, or just the standard web URL, we can now access our controller 3560 through that IP address. So now we're being port forwarded to our 3560. And in many cases, this IP address, which is now being used by the 4000, will be the IP address that you were using for the 3560 previously. So it should make it very easy to get to the unit and to access it. And you can see here on our 3560, the new WAN IP address is that 10.1.1.2 address. And remember, now that we've changed the port on our 4000, we can't get to our 4000 on port 80 anymore, because now our 4000 is on port 8080. So that's basically all there is to it. In this way, now we forwarded the default access for this IP address in the browser to our controller interface. Now, alternately, if you don't want to change the default HTTP port of your 4000 unit, there is another option under the firewall port forwarding, which is to create what's called a virtual server. And what a virtual server does is it translates one incoming port into a different outgoing port. So if we wanted to leave both our 4000 and our 3560 on port 80, what we could do is we could create a virtual server. The IP again is the same, It's 10.1.1.2. Since we're leaving the port of our 3560 at 80, the virtual server port, being the port that we're translating to, will be port 80. The original destination port we'll need to pick. Ports in the 60,000 range are usually safe ports. But you could really use any port you want. Sometimes people use 8,000, so let's make it 8001. And again, we'll say that this is the controller. This is a controller GUI. And now when we go to port 8001 on the 4000, it will be translated into a port 80 request and forwarded to the IP address of the 3560. Let's go ahead and apply this rule. And now if we go back to our IP address we were using before, but now we go to port 8001, you can see we have the same port forward to our 3560 controller. Now, an extremely important point to remember when programming virtual server ports is do not confuse the virtual server port and the original destination port. Because if you tell the 4000 to convert the original destination port 80 into 8001, what's going to happen is when you try to log into your 4000 on port 80, it's going to forward all that traffic to the LAN side. And so again, you're not going to be able to get into your 4000 anymore. And when you've done that, really you have to reset the unit to defaults unless you've opened up some other ports for some reason to the HTTP server. So please be careful when you're entering virtual server entries. So now we basically have connectivity to our 3560 controller. And when you set up your 3560 controller, in most cases you will have created a number of AP Manager entries. So let's take a look at our management page and look at our AP Manager. And this will be how you'll remotely access all your access points at the site. It might be 20 to 50 access points. And also you get a report on whether those access points are up or down. But what we need to do is, because the controller doesn't have a static IP address anymore, again, we need to port forward to our AP Manager entries. So let's take a look at the AP Manager setup on this 3560. Seems like the network's a little slow today. So you can see this is a pretty small site. We just have a couple entries here. But you can see we have some AP Manager entries using port 60,004 and 60,008. Again, we use these high number ports because it's unlikely that any other application is using these ports. But certainly if there's another open port that you'd like to use, there's no reason not to use those. But the 60,000 plus ports are pretty safe that no one is going to be using them for any kind of legitimate application. And in a similar way, the controller is forwarding this traffic to 60,004 to port 80 at this PoE switch, which is on the local network at 192.168.1.4. Now what we need to do is, when we have incoming traffic to port 60,004, we need to forward it from the 4000 WAN port to the controller. So the controller in turn can forward it to the PoE switch. And that's what will give us remote access to our PoE switch through the 4000 and through the controller. And you'll notice we're also using port 60,008. So we go back to our 4000, we can look at port forwarding, and we'll create a new port forward. Again, we're going to 10.1.1. We're going to send these requests to the controller 3560. I'm on the virtual server tab. Here's the port forwarding tab. So going back to 10.1.1.2, the easiest way to set up the AP Manager port forwarding is to use a range of ports, especially if you have 50 or 60 different devices. So we can do 60,004 through 60,008, and that's going to cover all of our APs. You might have 60,010 through 60,060. Now, if you want, you can enter individual rules device by device and have separate rules. But it's easier to use a range. We'll call this the AP Manager. And looking back at the table, now we have a port forwarding rule so that incoming traffic to port 60,004 through 60,008 is going to get forwarded to our 3560 at 10.1.1.2. And now if we go back to our hotspot and ask for, we'll do it this way. So if we go to the IP address of our 4000, which was that .65 address, and now we go to port 60,004, we now get forwarded to the controller 3560, which in turn forwards us to our PoE switch, which is at port 60,004. And that's really all you need to do. So the port forwarding process is very simple. If you want to use the AP Manager table under System Status on your controller 3560, you'll need to put in the WAN IP port of the 4000 into this IP address for AP URLs, because that will tell the 3560 that it's behind another device and what the IP of that device is. And once that's set, now we can go to System Status and go to the AP Manager tab, which is kind of a convenient way to see the status of all your APs, and then also just by clicking on them be able to get port forwarded to their interfaces. So we'll go to the APs tab and see what the status of our APs is. We can see our PoE is up. When we click on the link, now it's going to forward us through the WAN IP of the 4000 to port 60,004. So everything's working great now. Our port forwarding is working. Our AP Manager table is working. Also, we're able to log into the GUI of our controller 3560. So in terms of our management access, we're all set. Now, one more type of traffic that you'll want to forward from your 4000 to your 3560 is any additional public IP addresses that you're using at the site. And the most typical use for these IP addresses is for the VPN static IPs and the VPN auto IPs. So if you have a pool of IP addresses that you're assigning to users for the purpose of their VPN connections, or that you've added to the VPN auto pool that sort of is automatic, that automatically detects VPN connections and distributes the IP addresses that way. All of those, that range of IP addresses needs to be entered into the 4000 so that it knows to forward them to the controller 3560, just like those ports are forwarded. So if we take a look at our automatic VPN settings on our 3560, we can see we're using 73 and 74. Under the VPN static IPs, we're also using 71 and 72. So that 71 through 74 block are addresses that we need to be passing from the 4000 to the 3560 so that it can in turn pass them on to subscribers for use in their VPN connections. And the place where we configure that in our 4000 is under the routing, so it's under 4000 routing and under IP pass-through. This is quite simple to configure. Basically, you just pick the WAN port. In this case, it's WAN 3 that owns these IP addresses. The outside IP address is 170.133.189.71, and it goes through 74. The inside interface is going to the LAN interface, and in almost all cases, you'll want to bypass the firewall because you're using these as public IP addresses. We can add that these are the VPN static IPs. And once we add this rule, that's all there is to it. Now, one thing to watch out for when you're configuring this table is don't include IP addresses in this pool that you don't want forwarded directly to the LAN interface. So for instance, if you have a pool of addresses that goes from 65 to 78, and we're using 170, 133, 189, 65 on the 4000 aggregator, if we set that address to be forwarded, we're not going to be able to log in to the 4000 because it's going to forward all that traffic to the LAN port. It's never going to look at it. Another handy use for this table is if you have a different IP address for your 4000 aggregator, but your ISP has assigned you a CIDR block of routable public addresses in a different subnet, you can enter those addresses here, and that's an easy way to configure that CIDR block of addresses. And then again, all those addresses will get passed to the LAN side, and the controller can use them. So that covers the 3 topics of this tutorial: how to access the GUI of your 3560, how to configure the port forwarding for your AP manager, and how to configure public IPs that you want to pass through the 4000 controller to the 3560. Thanks for viewing this video tutorial. Please send us any comments or questions to support@valuepointnetworks.com. Thank you very much.